everybody. Myself Saurabh Ramesh Pawari. I am studying in MSc Chemistry Part 2, and I'm here to present my presentation on research methodology. Subject and topic is analysis and the presentation of data. Teacher in jar Dr. Rohini Mandhare ma'am. Topic to be covered: analysis and presentation of data, descriptive statistics, choosing and using statistical tests, chemometrics. Okay, I am going to be explain descriptive statistics and chemometrics. My colleague will Pallavi will explain choosing and using statistical test. Descriptive statistics. Descriptive statistics are the used to describe or summarize characteristics of samples dataset, such as a variable mean, standard deviation, or frequency. Inferential statistics. So basically, descriptive statistics is here we can learn about mathematical terms such as a sample data set, such as a variable mean, standard deviation, or frequency. Inferential statistics. This type of statistics can help us understand the collective properties of element data sample. This measure can give us a probability distribution or overall shape of data, which can be depicted on chart such as a histogram or dot plot. Knowing the sample mean variance and distribution of variable can help us understanding world around us. So these mathematical treatment can give us information more understandable. We can depict a chart such as a histogram or dot plot. This is a kind of graph, and we can understand more easily world around us. Let's then descriptive statistics classification. Descriptive statistics measure of central tendency such as a mean, median, and mode, and a measure of dispersion, uh, range, interquartile range, standard deviation, and variance. Then a central tendency. Then central tendency actually it's mean, median, and mode. So what is a mean? So mean is a uh, mean the mean average of a data set is found by adding all number in a data set and then dividing by a number of value in a set. Okay, so actually it is the average. Then median. The median is a middle value when a dataset is ordered from a list of least to greatest. So median is basically a middle value when dataset is ordered from least to the greatest. And then the mode. Mode is a number that occurs most often in a dataset. Okay, that is a frequently repeated. Then it's called as a mode. Median is important when our data has outlinear sorry, outliers, and mode is generally used when data is a categorical. So this is a chart. We can see the histogram, or we can say that this is a graph in our language. So we can see the mode, median, and mean. Then measure of dispersion. Okay, in the measure of dispersion, the range is the distance between lowest and uppermost limit of the given set of sample. So here we can see the 9 minus 3 is equal to 6. That is the range of the data sample. Then interquartile range. Interquartile range is the okay. We have a inner half and lower half and upper half. Lower half, upper half. We get average of upper half and lower half, and then get the average of upper half and lower half average. Then we get the interquartile range. that is a 53 plus 55 divided by 2 is equal to 54 is the interquartile range. Then the variance of sample variance is given by formula s square is equal to summation of xi minus x bar, the bracket complete bracket square divided by bracket of n minus 1 bracket complete. Then a standard deviation is given as a formula sd is equal to under root of summation of bracket ri minus r average bracket complete square divided by n minus 1. Then the importance of the measurement of dispersion. The range, it can give you a rough idea of how outcome of the data set will be before you look at it actually. Interquartile range, the interquartile range is the best measure of variability of the skew distribution or the data set with outliers, and standard deviation and variance measure the spread of the data distribution. More spread out the data distribution is, the greater its standard deviation. The more the spread of data distribution, data is the distributed more, then the greater the standard deviation will be also greater. Then some important terms. Standard error of mean, SEX is equal to S divided by under root of n. Standard relative standard deviation is given by formula RSD is equal to S under root of x bar, sorry, S by x bar. Coefficient of variance is given by CV percentage is equal to standard deviation divided by mean into 100. And this the example. Then the significant figures. All non-zero numbers are significant. The number 32.2 has a three significant figures because all the digits present are non-zero. The zero between two non-zero digits are also significant. The 2051 has a four significant figures. Leading zeros are not significant. They are nothing more than a placeholders. The number 0.54 has only two significant figures. The, the trailing zeros to the right of the decimal are significant. There are four significant figures in 92.00. Trailing zeros in a whole number with the decimal shown are significant. 540 dot point indicate that their trailing zeros are as significant, and there are three significant figures in this value. The trailing zeros in a whole number with no decimal shown are non-significant. Writing such a 554 540 indicate that 0 is not a significant, and there are only two significant figures in this value. And then standard deviation in calculated result, that is addition, is q is equal to mx plus ny. In terms of delta, we can have similar uh, formula. Delta q is equal to under root of m delta x square plus n delta y square. Subtraction is equal to q is equal to mx minus ny is equal to delta q is equal to under root of m delta x square plus n delta y square. Multiplication is equal to q is equal to mxy. Similar in we have in terms of delta q. Division is equal to q is equal to m into x divided by y. Power is equal to q is equal to m raised x raised q is equal to x raised to m and y raised to n. And logarithm q is equal to logarithm mx.